Hi everybody. I thought I'd give you a brief rundown on servlets from Chapter 30 from my book Java for Programmers. First question, what's a servlet? And the answer is it's a program that runs in a web server that makes use of what's called the Servlet API. It parses input from a HTTP request and provides HTTP responses by decoding HTTP data in the session layer and in the presentation layer. The first thing you need to do if you're going to run these things is you want to get a servlet container, and your first question is, well, where do I get that? And the answer is, well, Tomcat is a free open source Apache answer to that question. There are many. There's a available tomcat.apache.org with installers for Windows and Unix and Mac and whatever you like. Raspberry Pi. It's all written in Java, so anything that can support Java should be able to run Tomcat. For the install under Windows, you can get the EXEs. I'm going to try something a little different today. I'm going to do the install on my Raspberry Pi. I've never done that before. So I'll just get the binaries. This is the latest release for me. wget is a Unix command which gets the binaries straight away without having to use a graphic user interface. My Raspberry Pi has no monitor, no keyboard, so I SSH into it. And then I invoke the tar command, which does an extract of a compressed file. And here's the gzipped version of the file. Once that's uncompressed, I do a sudo. That's a super user do command. And apt-get is a Raspberry Pi or Debian Unix command. And then I install the ant command so that I can proceed to do builds. I cd into my Apache Tomcat, and I edit my configuration directory's Tomcat user XML file and add a Tomcat role with a Tomcat password and make it the GUI manager. And once I do that, I can proceed to do a sudo bin on the startup. And it says I'm using the Catalina base in my home where Apache Tomcat lives. And then it says, after a fashion, Tomcat has started. So let's have a look and see what's going on. We'll there is Tomcat running on port 8086, and there he is. That's the Tomcat invocation. It's what you'd expect. I know it's on port 8086 because when I go to my Tomcat directory, first thing I do is I type in ifconfig, and I can see I'm on TCP/IP port 218, which is consistent with what's showing in the browser. And in the conf directory, if I look at the server, I can see the connector port has been set to 8086. The default is 8080, but I've reset it. And so what that allows me to do is run the service on the port, and it will listen for connections. Moreover, I've modified in the conf the Tomcat users. And here you can see Tomcat users have been added with the manager GUI role. It's not normally there for security purposes, so you got to add that in. Then from the bin directory, you can see there's two commands. One is to do a shutdown, and the other is to do a startup. So after my my startup, I got Tomcat running, and because I have access to the manager, I can go into the manager and I can proceed to deploy or undeploy examples and servlets and things like this. And in fact, it should be possible for me to run some of the common examples. And here's some common servlet examples, and here's one called Hello World. And what we'll do is we'll take a look at the source, and apparently when you visit the Hello World application, it extends the servlet and then takes the HTTP servlet response, sets the content type to be text HTML, creates an instance of a print writer, and then calls out.println and outputs the HTML. So that's a basic Hello World application, servlet rather, and that's running on the server. And the entire Unix web server running Apache is a sub $40 Raspberry Pi. And it's a perfectly legitimate way to do your deployment. The performance isn't that bad, oddly enough. It seems to do pretty well. So that's an interesting commentary. You know, a little Raspberry Pi could easily saturate the outgoing side of an internet connection in the home. Of course, it's not meant for industrial strength stuff, but for casual deployment, for a convenient to carry with you web server, it's perfectly legitimate. So the whole communication protocol is done through a hypertext transfer protocol. We use queries and responses in a stop and wait protocol. So what that means is after a query is placed, you stop and wait for the servlet to formulate the response. And the web server is synthesizing HTML in addition to formulating the response. And you can get all kinds of interesting features from the servlet. You can have a nice object-oriented interface. You can do requests. You can get responses. You can parse HTML forms. And you can do what's called state management. State management's an interesting topic. So the first question is, okay, well, what's state management? And the answer is state management allows us to remember who you are and when you were here last time. So instead of having a memoryless request and fetch, we'll remember that you just did a fetch. So we can create a finite state machine which goes into a state that remembers your session. And so normally HTTP is without memory, and so then the question is, how do we store the state so we know that you are who you say you are and that you were here just now? And the answer is, well, on the client we have to store some data. And so what we do on the client is we push cookies into the browser's cache. And the cookies are typically enabled in order for that to occur, and the number of cookies and their size is typically limited. So then the question is, okay, well, what's a cookie? And the answer is it's just data stored by the client, transmitted as a part of the HTTP stream from the web server. So typical limits of a cookie are the size, 20 kilobytes per cookie. Usually for a domain, you don't have more than 20 cookies per domain, although I noticed my PayPal domain has 37 cookies. Not all browsers accept cookies, and in fact, you can turn off their cookies. And security can be a problem with cookies, so oftentimes they're encoded or encrypted in some way. Cookies typically have a life. You can set the expiration date on a cookie, you can delete your old cookies, and you can upload other people's cookies, which is another reason why you have to have cookies so that they're encoded. So the alternative to cookies, in case somebody turns off their cookies, is to do what's called URL rewriting. URL rewriting will typically start with a normal looking URL, and then it will add some kind of gobbledygook at the end, perhaps after an ampersand. And that junk at the end, that's what they call a UU encoded symbol. UU means Unix to Unix. The encoding is in base 64, and this will uniquely identify the URL and encodes the session. So I can do cookies or URL rewriting to visibly alter the URL, but now I can't bookmark my locations because my bookmarks will contain odd-looking gobbledygook. So I have to have an HTTP session, and that's going to enable automatic changeover from URL rewriting to cookies. It's part of the API, so you don't have to decide what to do. All of that can be done for you on the back end. So when you're a servlet programmer, you're a server-side programmer. You're writing programs that only run on the server. So an HTTP session has session management. It has a mechanism for changing from cookies to URL rewriting. It has an object-oriented interface to the session management, and I can pretend to write serializable instances to the client. So it looks like I'm saving things to the client when in fact I'm really saving it on the server and associating it with some sort of a cookie or a special URL. And things that I might like to save could include a shopping cart. So when you come back, you can check out even if you've been away for a while. So I need this Servlet API because sockets, while they may be sufficient, they don't give me a standard. The Servlet API gives me a kind of a standard that lets me get HTTP requests and HTTP responses, and I can read the requests and I can supply the responses. And so there are many interesting services and features that I can get. For example, Servlet Dispatch. And Servlet Dispatch says if you want to do a specific command, we can dispatch to the right command from our Servlet hub. And so when we think about dispatch, we think about a long multi-way change in the flow of control. We can get that from a case statement inside of a switch statement, or we can have a long if-then-else statement. And switch statements are typically a little limited. Normally you can't switch on strings, but here in the new age, I think it's as of JDK 8, we can now switch on strings. So switching on strings can now be efficient, and that means that we can build a large dispatch facility on the server that takes in a string and then does an invocation efficiently. One of the limits about the switch, normally you can't do the string, but that's now changed. You can do a switch without a string if you want to build some kind of a parser. You can map each string into a token where the token is a number, and then you can use the number for your dispatch. But now that switches can take strings, I don't think you have to do that anymore. And switching with a string typically was done by taking a long array and then figuring out what number maps to which array using a hash map, getting that corresponding token. And the hash map is nice because it's order n, or some constant, order constant time, but it's trading space for time. And it can take a lot of space in order to reduce the time. The if-then-else clause is order n, where n is the number of strings that you need to dispatch on. And another way you could do your dispatch if you're going to do a servlet dispatch facility was through reflection. So the reflection mechanism allows you to use introspection, and you can take the strings and try and map it into a class, but that has no type safety, and it's also a little bit slow. And there's no compile time checking. So it's got a couple of drawbacks. So I can build a parser-based reflection system. I've done this before. I use a class name and an instance of the class, and then you can invoke the methods. But now you've got to make a new instance. You've got to do it dynamically. That takes both speed and time. You can keep that instance around, but the invocations are going to change the state of that instance. And if you want to use an existing instance, the singleton, and invoke the method on that, you've got that problem with, well, what happens if two people are invoking methods on the same instance? So now you've got a command and response mechanism, and you have to decide how you're going to dispatch based on the commands that come in. So the dispatch processor, this is typical when you're doing something with a do login. Here comes the request, and then you provide a response. And when you want to do the log out, you do the same thing, request and response. And when you want to do a command, you throw in the string for the command and then provide a request and a response where request comes in with the parameters. And now if you want, you can use reflection to map the string into the command you want to do, or you can use the long switch dispatch. So the dispatch hub runs as a servlet. It gives you a single entry point into the system, and it's responsible for making sure that you have access, right? So that means that you have to make sure that they have credentials before you give them access to the back end. And then you can message forward to the dispatch processor. It gives you a level of indirection. The alternatives aren't particularly good. Here's do get, where anytime somebody calls a get facility, then you go in and you get a command out of the request, and then if it's do login, do the login thing. Otherwise, if it's do the logout, do the logout thing, and if it's this thing, then do that thing. It's not a very object-oriented way to go, but again, you can now use a switch statement after you get your command, and then do a long dispatch with the case. The if-else is pretty good. It's type safe, it's reliable, and that's not terribly slow for a large number of strings, but you can make it constant time if you use a switch. And so having something where if-else is going to take an order n time means not only do you have to have the if-else dispatch take a long amount of code, like you could have like n lines of code for n commands, but now you have to maintain it. You've got to maintain it by saying, look, here comes a string, and if you see that string, then invoke this thing, and then you have to take the thing that you're going to invoke and go and maintain it. And you've got to also make sure that you've added the string somewhere as a variable, so now you've got to visit your code in 3 different places. And that's kind of a nuisance. It's a poor way to do software engineering, poor way to do maintenance. So reflection-based dispatch is good. You just put the command in, and you don't have to update the dispatch processor, but it's not type safe. There's no runtime checking, and it's slower. So then comes the command pattern. That's another way to do dispatch inside of the servlet. That's not too bad, because now when the string comes in, you can have a runnable method that is associated with each string. But then you have to know how to do the dispatcher, so you'd have to put in a command string, then the dispatch that the command string associates with, and then you can do SD execute, whatever the servlet dispatcher does, and then throw in the do login mechanism with the request and response coming in from some sort of a global, perhaps final variable. So hash maps, that'll work for any string. It's possible that you could find a nice fast way to do a hash map with a dispatch, but it's generally speaking not compatible with reflection. So what'll happen is you'll get the string. You're not going to be using reflection. Instead, you'll be using that hash map to get you a token, which then does a dispatch. So that's kind of where we're at in terms of servlet dispatch. If we want to, we can take a look at some of the interesting examples that we've got running on the Raspberry Pi. And we've got the source code for most of those examples in the book, and also in the distribution for the code. So we already saw Hello World. Here comes something that requests info, and now we've got info about the computer that I'm on now. And here's the source code for getting the info. And here we've gone to the HTTP servlet request, which appears over here. And we do the get method, and now we can get the URI and the protocol, path info, all from the request. and even the remote address. So we can learn a little bit more about your browser. And here's the doPost method, which is calling doGet. And what happens in a form is you can have a form that does a get or it does a post. Here, if you do a post, it'll just defer over to the get. Parameters can also be parsed, but we don't see that here. Here's a parameter parser. We'll put in a parameter called hi, and we'll give it a name red, and we'll submit the query, and you can see it's being retained. Let's try this again. Blue, blue, and we'll try that. So these parameters are coming in and it's seeing them. So then the question is, well, how does that work? And if you go down to the developer and you look at the source, you should be able to see it. Let's see if we can find the source. Page source. There we go. So now we should be able to see a form, and the form should come in here with the action using the post method, and then supplying parameters from the text field associated with parameter first name, and another text field associated with parameter last name, and then a submit button, which feels like something you can press on the bottom. There's the submit. So then the question becomes, all right, so how do you write code for that one? Right? And the answer is, well, you're using the print writer to output just like before. And now what you're doing is you proceed to take in the HTML filter and use the first name. And you're able to get information from the first name. And you can use the same filter for the last name. And so what you've got is an opportunity to gain access to the parameters which are being submitted. Moreover, you can supply the form that was used to generate the data so that people can hit submit. Let's look at another one. Here's some cookies. Let's see what cookies we have. We'll put in a cookie, test, and the cookie value will be, and there, we should be able to retain the cookie. And now we see the old cookie is there, and here's the new cookie. They're being retained in the browsers. Let's try some more. We'll give it a value. And sure enough, we've got this cookie being sent, that cookie's still saved, and this cookie's still saved. So the cookies are being saved to the browser. Let's have a look and see how it works. We get the response. We go out to the print writer, and we can get the cookies from the request. And then to formulate something for people to see, we can go into the response, and we can just add cookies to the response and see things printed out for us. So that's kind of cool. We're going to go in and get the cookie name and then the cookie value. And then we'll get those things, make a new instance of a cookie, and add them to the response. Here's a session. Let's see if we can put in a session attribute or two. And so the session IDs are being used in order to store something. Let's see if we can now let's see if we can get the session attribute. And it looks like he's got the query there, and he came back with an answer. So that's kind of cool. So now here comes the sessions, and we've got a response which we're going to put in HTML. We'll get a print writer, and we'll use that to formulate some HTML output. We've got our session. Here's the HTTP session, which we'll get off of the request. And then we can proceed to look at the time that it was created, when it was last accessed. We can get the unique session ID, and we can get out.println to print these out onto the browser in HTML. And as far as attributes are concerned, we can go through and grab out parameters of any name. This one's called data value, and we can proceed to set these attributes. And here's a mechanism for getting all of the contents of a session, and that's pretty handy. And you can see what's going on. And so here's the contents of a session and some of the data that was found there. There's some more examples in the book, but that's kind of what I have for you for now. Hope you like my little presentation, Introduction to Servlets. Thank you.